So looking at worksheet 5, we'll do some of these. Arc cosine of the cosine of 4 pi over 3. Thank you, sir. Cosine 4 pi over 3 is, well, 4 pi over 3 is right there. Cosine would be the x-coordinate, so that would be negative 1/2. And then the inverse cosine of negative 1/2. Okay, inverse cosine has to come from 1 or 2. Cosine's negative in the second quadrant. And it would be 1/2 right there at 2 pi over 3. Unit circle, unit circle, unit circle. Number 24. Cosine of the inverse tangent of 2. Okay, well, it gives me a little bit of a hint. Use a right triangle to find the value of each. That suggests that it's not really a unit circle value. It's not. There's no place on the unit circle whose tangent is 2.
They're all right.
Tangent is opposite over adjacent. It's positive, so it's in the first quadrant. But how am I supposed to do opposite over adjacent if I only have one number there? 2 over 1. So the opposite is 2 and the adjacent is 1. That's also y over x. So you can use either way or both. Question?
Aren't they all right triangles though?
You mean use a right triangle to find the value of each?
Yeah.
Yeah, I guess that's just a hint. Don't draw something that's not a right triangle. Cosine is pa adjacent over hypotenuse, or x over r. Adjacent is 1. Hypotenuse, what am I going to have to do for hypotenuse?
A squared plus b squared equals c squared.
A squared plus b squared equals c squared. 1 plus 4 is 5. Square root of 5. So 1 over the square root of 5, which when we fix it becomes square root of 5 over 5. And then number 33. Oh, that's kind of a review question, but that's a good one. Let's see. Tangent plus cotangent over cosine. Any idea on what to do first?
Get rid of the weird one.
Let's distribute the tangent because tangent times tangent is tangent squared. That means one of those Pythagorean identities might be involved here. I think it will as well. What about tangent times cotangent? Those cancel out. So you can make one of them 1 over the other one, or you could just know that tangent times cotangent cancel each other out. So again, you can write one of them as 1 over tangent. You could write them both as sines and cosines. Best case scenario is you just know that tangent times cotangent equals 1. Tangent squared. This is definitely one of those Pythagorean identities, but I don't remember which one has tangent squared in it. So I start with the one I know for sure. Sine squared plus cosine squared is 1. If I want tangent to show up, I need to divide by cosine. So tangent squared plus 1 equals secant squared. Sure enough, it was a tangent or a Pythagorean identity, and it didn't even require any. Sometimes you got to move them around, but not this one. So secant squared x over cosine of x. That's not one of my answer choices. have which trade do you want to make?
This secant one.
The secant one?
Make it.
If I make the secant trade, if I change secant to 1 over cosine, then I end up with
cosine on the bottom over 1, then flip it, and then you multiply it.
Oops. Keep it, change it, flip it.
Yeah, and then you just cross them out.
No, nothing gets crossed out. 1 over cosine cubed.
Yeah, which is.
So is my answer B?
No.
No. What's 1 over cosine cubed?
Probably
Secant cubed.
yes.
The other way to do that one would have been to switch out the cosine for secant. And then when you keep it, change it, flip it on that, you would get secant cubed. But it's a good example of there's more than one way to get there. Good question. Number 30. Cotangent of the arc cosine of 2/3. 2/3, that's not a unit circle value, so I know this is a picture problem. It also is a pretty good hint that says, draw a right triangle. Arc cosine's got to be in quadrant 1 or 2. This one's positive, so it's going to be in quadrant 1. Cosine is, so ka toa, a over h, x over r, 2 over 3.
Wait, it's 2. It's not 1, is it?
Cotangent is x over y.
That's not a triangle.
Yeah, that's not a special right triangle.
Yeah.
3, 4, 5, 5, 12, 13. That's about it. 8, 15, 17. But this isn't that. So how do I find the missing side? A squared plus b squared equals c squared. Make sure that the c squared is the hypotenuse, right? So you don't add 2 squared and 3 squared. 9 minus 4 is 5. Square root of 5. And then x over y. 2 over square root of 5. And then we're still not done with this problem.
It's 2 square root of 5.
2 root 5 over 5. Well, that wasn't too bad.
Yeah.
The key is wrong.
Who is making these keys?
Well, this one's
Not me.
Miss Houston's key.
Oh, you can tell whose it is.
Yeah.
Yo.
She has root 5 over
She wrong.
Well, let's double check my work here. Cotangent is x over y.
2. I got that answer and then I checked the key and it was.
Okay.
Your answer's right.
That's what I get for posting other people's keys. I won't call them out on video, though.
You
I mean, you said it, but I'm not going to say it.
The x and the y values are flipped.
Common mistake. Even teachers make mistakes sometimes.
Yeah, it seems like it's on every improvement. It's funny how
Not the ones that
everything
do
works.
this.
No. You make those?
No. Well, sometimes.
Sometimes, usually we all do it and check. Sometimes somebody gets lazy. This time it was me who was lazy. And I was like, there's already a copy out there. Why do I need to work all this stuff? I'll just post that one. I'm still recording.
Yeah. I made a mistake.
Other questions from that worksheet? Those were all good ones. We hit some unit circle. We hit some draw pictures. We hit some of the old stuff.
No, we didn't.
We'll do general test review stuff tomorrow. Are there questions, odd questions, that you want to work off of worksheet 6? Anything you want to see?
Can we do 7?
Number 7. Oh, back to the proofs.